Welcome, everybody. Chemical Consultants Network is a nonprofit organization of over 200 consultants. I think it's 375 as of the last count. So we're doing great. Of chemists, chemical engineers, life scientists, and other interested scientists and engineers of other chemically aligned disciplines. We hold monthly meetings on topics of interest to consultants to help start, practice, and enhance consulting opportunities. Our meetings cover common issues such as taxes, regulatory compliance, safety, and technical developments in science and technology. Through our website, we provide a platform to advise potential clients about our area of expertise. The Chemical Consultants Network is supported by the Philadelphia section of the ACS, the American Chemical Society, and the American Institute of Chemical Engineers. Thank you very much all for coming. And without further ado, I'd like to introduce to you Roman Bielski, who's going to introduce our speaker. Roman?
Good evening. It's a pleasure to introduce our speaker today. I have known Ken almost since the previous millennium. Almost. He's a wonderful chemical engineer. We worked together at a certain point a lot, and we are two. I was a chemist, he was an engineer, and if things were screwed up, it was always me. He spent his life working in the States, in France, Benelux, many years in Europe, and he designed and was involved in designing of plants in Europe and here in the States. And he works as a consultant for many years. He's, as I say, wonderful engineer, and you'll see it during his talk. He has tremendous knowledge, he's a good speaker, and I hope you'll enjoy your talk very, very much. Ken.
Thanks, Roman. Okay, if you have questions, it's a small group, you can kind of chime in, but Joanne set up the chat board. If I see something that's interesting that I want to break out and answer your question, I'll do it right away. Otherwise, maybe we'll do it at the end. So anyway, what I'm talking about here is the design and operation of pilot plants. I started out in in a plant technical commercial plant, kind of worked my way backwards into pilot plants and then into engineering, and ended up doing quite a few pilot plants. I think the next slide will give a list of them. So I'm going to talk about my history with pilot plants. And I will say that most of them, and my emphasis through 60 years has been predominantly polymers, but I have done some organic chemistry, a bit of refinery, a little pharmaceutical, but agricultural is one listed. But going to talk about why we build a pilot plant, setting the criteria for success, layout and design, most common pitfalls, and some of those, there are a lot of big pitfalls. How to budget a pilot plant, operations. I try to avoid specific polymer items in the text, but there is a reference at the end that I stole some goodies out of and added into my slides. I'll tell you in a minute, the first time I did this slideshow, I'll tell you when I did that, but when we get there. So way back in '68, I started for Monsanto when Monsanto, all of their styrene polymers were made by batch aqueous processes. When I left 16 years later, most of them were made by continuous mass processes. And I was right in the middle of the pilot plant, starting up the plants in Cincinnati and later in Europe, both France and Belgium. But the first, and these are kind of the history. You know, I could go on for a half hour about 2 or 3 of these subjects, but I'll try not to do that. The first pilot plant, basically my manager in Cincinnati said, hey, they're going to build that plant here in our plant. They're doing all of the R&D, and the pilot plant is in Springfield, Mass. Get your ass up to Springfield and find out what it's all about. So all I heard for the first days was how congested this pilot plant was, and they griped at Central Engineering for building it so that it was impossible to maintain, impossible to operate. But I happen to be good friends with the Central Engineering project manager, and he said they told us build it in a shoebox, and we told them over and over, you're going to hate us, and they did. Actually, when I got there, they had already cut a hole in the ceiling about 8 foot square and raised the reactor, I don't know, about 3 foot, and that freed up a little space, but it was impossible little plant to operate. But it's always, you're going to hear this, well, we're only going to run it for 3 or 4 months, collect some data, and then design the plant. You'll see that again. So we don't need all that instrumentation and stuff, and we don't need it to be easy to operate. And the other problem was that their operator and technical staff were working 5-day weeks. The operators worked 3 shifts, but 5 days. So here, this was a continuous pilot plant, and the operators would come in Monday morning to run plan and be sitting on their desk, and it took them 8, 10, 12 hours to get it started, or something had broken the week before and maintenance didn't show up, and sometimes they didn't get the thing running until Wednesday afternoon. And then it has to all be shut down and safe by 3 o'clock on Friday. So here was a continuous plant that was starting and stopping all the time. And my manager back in Cincinnati, and then maybe I'm getting ahead of myself. Yeah, I'll talk about that later. So Monsanto, they were then developing another process. The first one was for styrene acrylonitrile copolymer. The second ones were for all of their grades of polystyrene, impact, and crystal polystyrene. And they built this gorgeous building with lots of room and all this space and all. So they had learned their lesson. And that plant was a dream to operate. I only was a spectator there. There was a whole other team, but I looked at this one and said, ugh, and then looked at that and I said, boy, do you guys have it easy. I eventually ended up, for this first process, ended up starting the first of those commercial plants in Cincinnati, and then started the second one up in Antwerp, and then went on the polystyrene plants. I started up 2 of them in France. So I know what it's like to get from the pilot plant to the commercial scale. Sometimes that goes easy, sometimes less easy. I packed up and left Monsanto, 10 years an expat in Europe, and I quit. I don't think anybody ever does that, but I did, because they had this nice pilot plant Uniroyal Chemical was building in Baton Rouge, and I was going to work 6 to 8 months in the pilot plant, and then go to Connecticut and design the full-scale plant. Yeah, we're only going to run it 6 or 8 months, then design the plant. Oh, I've heard that one before. This was they had a large budget. They had operators for 24/7, 2 technical staff, myself and 1 other. And yeah, we covered 24/7 too, 2 guys. It was a tough haul. The key point here is this one here, is that this pilot plant was designed as a continuous polymer pilot plant. And it was big. It had 3 distillation columns in it besides the polymerization and so forth. But it was designed based on batch data. And the batches only ran for like an hour or two. And then they shut them down, cleaned it out. And a long story short, we beat our head against the wall trying to run the pilot plant in Baton Rouge for, let me say, a year and a half. And we could run continuous reaction for about 12 or 16 hours. And then the whole plant would be plugged up with polymer. And I've had executive vice president at 2 a.m. in the morning in the pilot plant break area screaming and yelling, threatening me with my job, but I didn't work for him. I wasn't worried about him. But anyway, they had, I went back, I took a trip up to the research center in Connecticut, where some of you know Naugatuck or Middlebury, Connecticut. And I said, I want to watch 1 or 2 batches. Just tell their technician there that I'm going to sit and watch, just take notes. He just do what he's going to do. And when he finished the batch, he dumped the polymer slurry out of there, collected that, got his samples and so forth. And then he filled it with toluene, the reactor, turned the heat on, soaked it for 2 hours, drained the toluene, opened up the reactor, and it was this 1/8-inch film on the wall. And the reaction had only lasted like an hour. So he's there with this long spatula, scraping the polymer off the wall. And that's 1 hour. So I went, I was furious. I told him, I said, you got to run 10 batches back to back, pick your favorite recipe, just run them back to back, no cleaning, no toluene, don't open the reactor, just run it. Well, my little memo went all over Uniroyal, and about a week later, we get a phone call, said they're shutting down the pilot plant. The chemistry plain didn't work. We were making 2 polymers in the reactor at the same time. One they wanted, and the other one was stuck to the wall. So they did that based on this batch data, and then they designed a continuous pilot plant. I'll go what we did afterwards, because we had this beautiful pilot plant. The 2 chemists that worked on this Uniroyal chemical, they retired and went to Mobile Chemical. I don't know if any of you guys, when they were MRDC in Pennington. So some of you probably know about that place. It's all something else now. This was the first time I was hired as a quote unquote consultant. I worked for an engineering company at the time. One of these chemists called me up and said, hey, Mobile is going to build this polymer pilot plant. And although Mobile had done lots of pilot operations and catalysis and refinery type stuff, they'd never done a polymer pilot plant. So they asked me to come up and spend a couple days with them to help them with their design of the plant, and there'd be some residual work afterwards. I'll get back to that guy because that's a big piece of what I'm presenting here. I did pretty much a paper study. Rensselaer Polytech had some patents about, they weren't really for plastics recycling, but they adapted them because what they wanted to do, nobody was funding, but you could get lots of money to do plastics recycling. So they, as a good university would do, they went for the money. So I designed a pilot plant for that, did a very preliminary commercial design, knowing that this thing would never get built. The technology was way too expensive. It didn't make any sense. But anyway, I made some money on it. Now I did do, this was an individual, it was a gas processing pilot plan. And this one, he did it real small because his plan was to take this process out to the field, let's say to a gas well, natural gas well, and take a little side stream. So he built the whole pilot plant in 2 trailers. One trailer had all of the process equipment in it, and the other trailer had all of the instrumentation, including several online chromatographs. So he did something small, but it was really well laid out. So size isn't the only thing. There's you cram a lot of stuff in a shoebox. Well, that's one thing, but if you do the layout right, and he didn't over install. So I only got to look at that. I never ran that pilot plan. I was kind of helping him out. I did a pilot plant totally out of my league from technology. The Agricultural Research Institute of Australia hired me to do a preliminary design, and they really were after the estimate. And you know, they gave me all, here's the equipment we want, and I did layouts and priced it. And I said, I don't know how much it costs to build a building in Australia, so my estimate's just the equipment installed, connected, piping, and so forth. And they, I said, you guys go get a price for the building. I knew my estimate had to be pretty good because their response to the estimate was, it's a little more than we thought it would be. So I knew I was on target. Everybody thinks it's cheaper than what's real. I did a project, I guess I was working for Jacobs at the time for Honeywell. And if you know Honeywell, they do a lot of fluorine chemistry. And once again, they built this pilot plant in an elevator shaft, literally. It was an old plant in Buffalo or Niagara Falls, somewhere up there. But they put floors in the elevator shaft, and my piping designers went nuts for 6 months trying to lay it out and fit everything into it. And I thought, I didn't put it down here, there was another lessons learned on this one. And this, not just for a pilot plant, but also for a commercial plant. If you have any one-time startup procedures that you may never do again, but you're going to do them the first time, the engineering people need to know about it. Honeywell procedure before they start up a new unit is they passivate the piping with 50% fluorine gas. And I guess it's 50% nitrogen. And process unit, all the materials of construction were fine, but at the end of the line, all of the vent streams went to a caustic scrubber that was PVC. And you put 50% fluorine through a PVC pipe and it burns. It literally, they had a fire. The PVC pipe just literally burned. And of course there was, oh, that's the engineering company's fault. Well, they never told us about the using straight fluorine gas. They used other fluorine chemicals, but not fluorine straight. This CCN Polymers, they're a nylon 6,6 plant. That's an old DuPont design, but it was owned by Monsanto. And as all companies get shuffled around, this one I wanted to bring up because they asked me to help them design a new devolatilization part of the plant, removing the volatiles at the end. But they have a commercial plant there with running the reaction day in, day out. They have utilities and so forth. Everything's there. And all they needed to do was test a couple of unit operations at the end of the plant. So the concept was, you don't have to build the pilot plant with all of that other stuff in it. You build a small skid unit with the test equipment, only the pieces that you need to develop that need to be piloted. And you take a side stream off the side of the main process and feed it to this pilot unit operation. So that's sort of my history on pilot plants, with a few war stories in there. Now the first time I did any slides on the pilot plant was for those mobile chemical guys. When they asked me to go up and be a consultant, to give you an idea what the time was, my presentation was done on transparencies. So it was a couple years ago. But I was in a room with 10 of their stakeholders, everybody that wanted this pilot plant. And I said to them, I'm going to go around the room and I want each of you to tell me their 2 most important reasons for building the pilot plant. Just 2, but that's most important to them. And from 10 participants, I got 9 answers. I had the next slide ready already, and I only had 8 of the 9. They came up with one new one I didn't think of. So why do you want to build a pilot plant? Kind of, who wants it? And I have here a whole list, and I think all of these were on the mobile list. Maybe I've embellished it a little bit. Hey, they need, and this is again a difference between the polymer business and say organic chemicals. If you have a new catalyst for whatever, cumene or something, or cyclopentacrap, whatever it is, your design, your product samples are normally, you're going to test them on a chromatograph, all those other clever tools you chemists have, GC mass spec and all this kind of stuff. And it's going to, so you design to an assay, and maybe there's a certain impurity that has to be below something. In the polymer world, you can test some of that kind of stuff. You got melt index, the flow properties, impact testing, gloss, transparency. But the only one that really matters is the customer. So you have to get samples out to the customer if you're making a new product, or if you're making the old product by a completely different process, which was the Monsanto situation. So the pilot plant, everybody, well, R&D wanted samples for testing. Marketing, they wanted samples for customer trials. Engineering and R&D, they wanted the kinetic data, operating data. Engineering needed to collect scale-up data. And this was one with my manufacturing hat on, is how operable, if it's a continuous process as opposed to a batch one, is it really operable on a 24/7 schedule? In the case of mobile, it was going to be a batch plant, but that one's from my history with the continuous ones. And then when you have a continuous plant, you need to test recycle streams, how much impurities are building up. So R&D and engineering need to know that. What are they going to do with the impurities? Long-term fouling, I wonder where that one came from. But you have equipment but if it's a new catalyst or something, people look at catalyst fouling and stuff. Never been my worry. As in the Ascend nylon case, we're specifically testing unit operations, but all these other pilot plants all kind of tested unit operations of some kind or another. And this is one that I got into. You want to test real equipment, not glassware laboratory device in something that you can't buy a bigger one of, or it'll cost you gazillion dollars to make it in a full-scale commercial. So that's when you design the pilot plant, you have to think about putting equipment in there that, yes, is smaller scale, but it has to be scalable. Someone needs to be able to build it, be it custom or a vendor apparatus. Hey, there might be some alternate flow schemes that haven't been worked out, recycle and things of this sort, cooling, optimized cooling, these things can be done. They could be other reasons why you build a pilot plant. And hello there.
No.
The test, manufacturing guys say, well, okay, you ran that for a week, or 3 days.
Are you kidding me?
Make the same stuff next week. And Ron, were you going to ask a question? No, you're gone. Okay. And this is where I've said, it goes back to this thing about the real equipment, small scale commercial equipment equivalent to lab produced. Basically, if you work with a manufacturer, I have no problem with that you build your pilot plan around the smallest model of a manufacturer's piece of equipment. He knows how to scale it up. That they can do that. But it's got to be the commercial equipment at a small scale, not a big lab scale unit. And okay, this comment was a little different, but it was just that, hey, the stuff that we made in the lab is the same stuff you made at the pilot plant scale. So depending on where your emphasis, okay, Joanne, I see your note. So if there's an emphasis on 3 or 4 of these, you might build a plan differently than if it was based on other things. And that can get into so you need to set some criteria for success. Look at those important reasons on the previous slide, rank them, and what do we need to do it? A lot of it may deal with instrumentation. Is that depending on which one of these items, if you're only looking samples for testing, who cares about the instruments? But if you want to collect the data and design a bigger plant, then you need some instrumentation to find out what the plant is doing. That's maybe an extreme case, but this emphasis will help you set the design criteria. How big should it be? What's the life cycle of the pilot plant? Do you have spares either installed or sitting in the hallway ready to install? The level of instrumentation, and this is where I said small commercially available units is preferred. I'm just looking ahead. I have a question. I thought it was on this slide. Okay, and then how much of the process to include? you have a new process. I think most of my audience here tend to be chemists. And, but I guess if you're working on some chemistry of a new product, somebody wants to make it sometime and commercial and make some money. So, but one of the things I often ask, and when I was at advisor at Drexel to the senior design students, these two, I ask them, what do you know? What don't you know? And the pilot plan's got to work on the what you don't know. If you know stuff for sure, maybe you don't need to pilot that. So maybe you only pilot the new technology, and that's what I said in the nylon plant. The plan was to go side stream from a commercial plant. One nice thing with that is if you need utilities, it's all around you in the commercial plant. The downside is you may end up jammed in a little corner of a busy operation, but I think that's a good approach for many pilot plants that have this, that you're looking at the what's not known, that you don't need all the other stuff because you know about that. Oop, I got a big 2 questions for your pilot plant. Yes, we had to handle HF. I'm going to mention safety here later on. Determined. Okay. All right. I'll get to those guys. That's fine. Thank you. So the layout and the design, you know, obviously you've heard me, don't build it in a shoebox, don't build it in an elevator shaft, and leave space for abnormal operations, and the big one is changes. If you knew everything about the process, you don't need to build a pilot plant. Obviously, there's some unanswered questions that you're building a pilot plant for. So assume that what you build first isn't going to be what you end up with. So how are you going to do that? You may have to take something out and put something in its place, redo piping. That Uniroyal pilot plant, we took it apart every 2 weeks and put it back together again. The size and the capacity, well, that's got to match your success criteria. If marketing wants samples, how much do they need? How many products are you going to make? Things of this sort. So the answers to those questions determine the size and maybe the flexibility. I guess I like this part about the small commercial equipment. Now I was going to ask if anybody wants to jump in. What typical scale-up ratio would you think is a good number? In other words, not to the pilot, from the pilot plant to the commercial plant. Anybody have any thoughts? No. Too many lab people.
I would say 3 to 10, definitely not more than 10.
And like I said, it's not as important, Penny. The Monsanto pilot plant, the CCN one, 72 to 1. And it worked. And I've done pilot plants 100 to 1, and they worked.
Well, can you have a set of pilot plans? So you go from a laboratory to something bigger, and then into a pilot plant, and then into a bigger pilot plant, and so forth?
I guess this scale up, I'm talking, now you've built the pilot plant that is being used to design the commercial plant. I guess that's the piece of that. If you go from lab to, I'll say, a bigger lab or a little pilot plant, you're still, I'd say, working in chemistry a little bit, maybe some unit operations. But
my point is that if you are taking a look at what Ron's point is, that you should not you don't want to upgrade too much, because then there's going to be too many variables that are different. Now, I don't have any experience with pilot plants, but I think that what Ron's point is well taken. If there's a small problem in pilot plants, it's going to be a bigger problem in a commercial plant.
right, that's why
tremendously, right? And
that's why
so,
you run the pilot plant long enough to not have those small problems. And
okay, but I mean, is it there is a good thing about having pilot plants that are just one order of magnitude instead of two orders of magnitude bigger than the pilot plant. I mean, is it true that pilot plants that are only 10 times the smaller than the final pilot plant, it gives you better data, gives you better design parameters than if you'd be 1 to 100?
certainly,
Yeah.
and you'll add another 2 years to the program. And if marketing people want the product built, that's where you hire engineers.
Yeah. Okay. Got it. That makes sense.
That's what
Thank
we
you.
do.
This is Mike Clater speaking.
Yeah,
I'm relatively new, but I think it depends. I was going to say 100 to 1 as well before you said your answer, but I think it depends on the unit op. I mean, there's some mixing tanks and stuff that are pretty easy to scale, but if there's all kinds of transport issues, reacting flows, it can be a lot different. But I use 100 to 1 as a.
yeah. I like your number. Like I said, the first one I dealt with happened to be 72 to 1. We ran the pilot plant at 100 pounds an hour, and 7,200 pounds an hour comes out 50 million pounds a year when you put in the operating factors and stuff. So that was the design of that plant. But I'm comfortable with 50 to 100 to 1 on a well-built pilot plant that you're going to collect data and run it long enough to figure out those recycled streams and all those other engineering issues. And then you turn the engineers loose and they'll build your plant that'll work. As long as it can.
It also depends, maybe you'll talk about this on the scaling parameters. I mean, you can't keep every dimensionless number constant.
No, in a polymer world, yeah.
You have to pick the right dimensionless numbers, I think, and be cognizant of the others.
Yeah.
A perfect example is going from laminar to turbulent flow or something, where it might be laminar at the pilot scale, in 1/4 inch.
Well, we kind of went from 50,000 centipoise up to 500,000 in those pilot plants, the polymer pilot plants, and the plants. So we were pushing things. Everything was laminar flow.
Yeah, that's
in the real polymer piece of it, which was where all the technology was. And here's another one: is build in some longevity beyond the current objectives. You spend all this money on a pilot plant, you got some good equipment there. Hey, you run off and build a commercial plant. That pilot plant's probably good for something else. You may not have, and it may have to be versatile, that you can that you should plan for a wider range of conditions, temperatures, pressures, and such that are beyond the design parameters. You have a recipe and you say, oh, it's at this temperature, this pressure, it runs steady at that. It's a good idea to design the pilot plant that's more versatile than that. seals, valve, piping instruments, you don't want to find out that, oh, we got to raise the temperature 50 degrees and you find out a seal is going to fail because it's out of its temperature range. To go back to this versatility and this long range objective, that pilot plant in Baton Rouge, that Uniroyal Chemical, after a year and a half of us beating our head against a wall because the chemistry was wrong, my colleague and the operators, we all looked at each other and said, what are we going to do tomorrow? Because they just told us, shut it all down. Well, my colleague got on he had heard some information about they were working on some new products up in research. He went up there and said, hey, I can make that in that pilot plant. And he came back and we made a few changes to the pilot plant. And it took us 8 weeks to develop a recipe. And 6 weeks later, we delivered the first 55-gallon drum of product to a customer. With this pilot plant was beautiful equipment in it, gorgeous. It just was making the wrong product. But so some versatility, and that pilot plant actually got scaled up after I left Uniroyal, and they made it. I think that we were thinking about it while I was still there, scaling it up to semi-works. The product was successful, and they debottlenecked it and added some bigger equipment, and I believe it's still running today, making product.
Ken,
Yeah,
I got a quick question for you.
Sure.
These situations where you said that you could scale up 100 to 1, has that been done with completely novel chemistry, or were those situations where they were adaptations of known chemistry? Because I'm an industrial biochemist. I've never heard of 100 to 1.
In the polymer world, it's all you're piloting unit operations typically. The chemistry, yes, some of it's changed. If you take a look at it was Union Carbide that developed the gas phase polyolefin processes. I think their scale up was at least 100 to 1. I'd say the chemistry was relatively well known. And it was more equipment related and reliability and so forth. And though they tried it on another similar process, what Uniroyal Chemical was trying to do in Baton Rouge, they tried to do in a gas phase plant, and it didn't work. When Dow ended up acquiring Union Carbide, they shut the whole thing down. Well, they actually converted the plant to polypropylene, I believe.
Most of the guys that I've had to work with have had to deal with the new chemistry.
Yes, and I know this CCN is pretty dominated by organic chemists and maybe pharmaceutical type people, and I always seem to be the odd guy out with the engineering. But yeah, I would say that's another world. I'm not sure what is I know some people at Merck, and when they have that pilot plant, I guess not in Rahway, but just down the road from there, and it's a very they built it as a generic pilot plant, could make, the chemistry wasn't set. I don't know if when they did that, what sort of scale up ratios the pharmaceutical world does. I don't know. Okay. I got my favorite subject I haven't gotten to yet. Oh, capital budget. So I think from all of my kind of lessons learned, one of the big problems is over optimism. We know everything. Well, if you know everything, why are you building a pilot plant? You can go ahead and just build a commercial plant. Well, we need scale up data, we need some operating data, but we can do that. Build it, run it 3 months, 6 months, shut it down, go design the plant, maybe keep it running to make some samples. Don't count on it. Not in the polymer world anyway. You know, don't think that the first design is the final design. There will be changes, sometimes substantial. And of course, here my batch data to directly design a continuous plant. Oh my God, what a mess. Insufficient budget. Well, all of this changes in design, and the fact that you think you're gonna run the pilot plant for 6 months. I know I was sent back to Springfield to help them run, I'm up to it here, I packed 2 pairs of jeans.
Hi, good, good. I was on the conference call. Well, it's like a webinar.
Okay, thanks, Adam. I packed 2 pairs of jeans and a bathing suit. It was May, and I went off to Springfield, and came back a year later. Had to go fetch some cold weather clothes along the way, but that has to be budgeted for, and the changes and the maintenance. And Monsanto initially didn't do any of that. They said, no, we're going to run it for 3 months, get the data, build a plan. Uniro, pretty much, they didn't count on anywhere near the amount of changes we had to do in that plan. And then, of course, too little space. Give yourself room. If frequent cleaning is needed, it's not a realistic process. Impurity buildup and recycle streams. Some people will use, for simplicity, just use fresh raw materials all the time. And throw away the purge streams, whatever. Don't throw them away. We had a big commercial plant right behind us. We could put everything, just put it in that plant, and it disappeared. It was huge. So you need to look at when there are recycle streams, you got to use them. Yeah, you got fresh raw materials going in, but eventually you got to recycle. And then this is one of my favorites because I've seen this done at times when piece of equipment, they might take it out, have it built in a machine shop, works fine in a pilot plant. Absolutely no way to scale it up to 100 to 1. We can't build it. And my voice is going to die.
Manager, yes, manager, you're on.
Yeah, I get talking too much. I like my first bullet here on capital budget, operating budgets. So we need to get this process developed, designed, build a plan, shut down the pilot plant. Well, you need to expect and budget late additions for modifications. And this is, Monsanto had a way to do this. Uniroyal struggled with it, but having a budget mechanism for significant changes. And so in your initial capital request, if the pilot plant is going to cost $2 million, go and budget, ask for $2.5 million. Keep the $500,000 in your pocket because so that when these changes come, you don't have to go back to the managers and say, hey, we need another $200,000 next month, another $200,000 after. You have the money there. So that should be built into the original capital budget, is money to make changes. This is my, if you sure it's going to work the first time, why build it, right? Space. I've said it's usually not expensive. Hey, in Monsanto's case, they could have found a better place where they built the second one. They found the space for that one. And then this is real equipment, smaller size of a commercial unit. The vendor scales it up. Said that before. Indoor versus outdoor. Now you got operators, technical staff, etc. Well, everybody like to be indoors. Doesn't matter whether you're in Baton Rouge on the hot end or Springfield, Mass on the cold end. We're comfortable indoors. But safety-wise, outdoor plants are much safer. If you have any kind of volatile, flammable materials, outdoors is the way to go. Maybe a roof over it, but open sides. And another thing about I got some more safety items here, and I'll answer the question asked. This skid building is almost always going to be cheaper. That there are lots of guys out there, companies that can build you a pilot plant on one frame, steel frame, maybe 2 or 3 steel frames, depending on how big, what the scope of the plant is. He's dealing with small equipment. He doesn't need cranes typically, maybe a little cherry picker in his shop or something, but it can be all put together. And one of the nice things about that is the instrumentation. All the instruments get run to a panel that's pre-wired from the instrument to the panel, and then you have an umbilical cord goes to wherever your control system is, which doesn't have to be, it can be indoors, your control system, and once things are running, started up, you can operate it from there. But I like skid build. I've talked to several people about building pilot plants that way. And then I'm broken record a little bit. Plan for longer, and it's where pilot plants don't make money. So managers don't like that. If it's for continuous process, certainly 24/7 operation is best. 24/5 can work for some continuous processes. As long as it's reliable, it starts up Monday morning, you run it till Friday afternoon and shut it down. That'll work. And you can still have recycle if you get it up and running. That first Monsanto unit, it was always falling apart and you couldn't repair it. And so it was the 24/5 turned into 1 or 2 days running. And I gotta get, okay, I didn't tell my story here. Because that first pilot plant ran on this 24/5 schedule, it never ran more than 2 or 3 days. Well, my bosses back in Cincinnati that were going to have this plant built inside their plant said, wait a minute, this is a continuous plant. And they drew a line in the sand and said, that unit has to run 1 month nonstop. No shutdowns. For 1 month. Then if you can't do that, basically they said you aren't going to build it in our plant. So that they got into the Oh my God, the budget again. You know, we don't have enough operators in the pilot plant. We're going to wear out the technical staff. Well, my boss had the answer to that. Oh, we'll send you Ken. You can go up there and help out. Well, I went there and my job for the next year was keeping that pilot plant running. It broke down and I was spent time in machine shops getting things rebuilt. But anyway, the line in the sand moved a little bit and they agreed 400 hours. So we went on a 24/7 schedule, 3 engineers, 6 operators doing overtime and such. And we did our 400-hour run, and then the plant said, okay, you can build it in Cincinnati. So that's another thing is budget for your testing. You know, the R&D guys say, well, we do all our own tests. Well, okay, but if they're out of town in another location, you're sending samples and you're waiting and so forth. So you need to combine all your technical resources, maybe use third-party outside testing. I've done that. The R&D, you got plant technical. When you're in an operating plant, you got nice big labs. They need to maybe learn a few new tests they didn't know about. And then you got corporate specialists for whatever. And this was one that I maybe was the first person to do this, and Monsanto would have never done this. They were in union plants, but the non-union Uniro plant, the pilot plant technicians did their own lab analysis. We had an FTIR in the control room. The research guys came down, taught them how to use it. They did the testing there. There was a few tests had to go to the central lab, but you can never count on them getting the results back when you wanted them. When you do it yourself, you need the results, you get it done. So budget, again, I'm talking budget, you need raw materials, waste disposal. Oh, is there waste? Well, yeah. Testing, utilities, operators, technical staff, which are going to get burned out probably, and maintenance are bolded, because that's, what do you need maintenance for? Well, because it's going to break down. So, okay. Safety was a question. Yes, we were the Honeywell's elevator shaft. We were HF was I'll say the primary raw material or the primary hazard. The fluorine gas we didn't know about. Like I said, that was a startup only thing. And again, it was in the elevator shaft was indoors, so I didn't like it at all. But it was in Buffalo, New York, and it's going to be pretty hard to operate that outdoors in Buffalo in the winter. So I had issues with that. Nothing I can do about it. The Honeywell people are pretty hard-headed, but anyway. But on the safety side, one of the things that I say, it's a pilot plant. You're doing something different. You may be, you know, you have operating procedures and so forth. When I was Uniroyal Chemical, it was early days for management of change. I don't know how many 100 management of change forms I had to fill out in that pilot plant. But you're going to be asking operators to do something different today than he's done for the last week. Maybe something completely different. But we got to try this or do that. And so you need a mechanism to handle change and to do it safely. And there's physical changes. Hey, we ran some new pipe or bought a piece of equipment. And then there's recipe changes. Both of those, maybe a different raw material you didn't use before. So you have all of those that you need a real management of change position. see if I can get this slide all in back on its one page. Yeah, the so the schedule, I said, even when you're running continuous 24/7, build in some outages. Because everybody's going to be burned out if you keep running your technical staff and the operators 24/7. You can catch up on the data, lessons learned. What do we do next? What are we going to do? You need outages for modifications and repairs. So that's got to be in the schedule. And if you're saying, oh, we're going to do this in 3 months, the modification and repair might take 3 months. So here about the schedule, if there is issues of impurity buildup, fouling and operability issues, you got to get to a 24/7 schedule. And kind of things I learned, the operators and technicians, again, you're doing something new. Nobody's done this before. Talk to your operators. They're your eyes and ears. Listen to them. They see stuff that you didn't see. You know, they say, hey, you know, such and such happened last night. Tell me about it, because you didn't know that. Ooh, Jen. Okay. And now I'm down to my last slide. I just put a reference in here. Like I said, I tried not to orient this to polymers, but obviously it was. There's an article here that I kind of stole some of my bullets out of. That's why some of them kind of got duplicated in places, and it was very useful. And that's specifically for specialty polymers he did. And then I'll get to questions. So the Honeywell one I didn't answer too well, but the fouling issues. No, they didn't put coupons in. I've used coupons in pilot plants, yes, and that in reactors. Matter of fact, we may have actually put one in the pilot plant reactor at Uniro. The R&D people, they don't care about materials of construction. All they know is chemistry and product. So like I said, it didn't take long after I sent my memo out to the world that hey, run 10 batches back to back and tell us what the reactor looks like, that all of a sudden I was nearly out of a job. I know what the result would have been. They would have had a 3 or 4 inch layer of polymer on the wall of the reactor. So, because I'd seen it on my reactors after 16 hours of running. Hardly was room for the agitator to go around.
And I thank you, and I value your wisdom.
So if anybody's got a pilot plant they want to build, let me know. I listed my typical deliverables. I do basically just front end engineering now. If somebody gets beyond my front end engineering, I recommend to them. I have 1 or 2 engineering companies that I put them in touch with. And actually, Roman, are you still on? Yes, you are. Roman, I put Peter Joyce in touch with the one engineering company in Philly, and he's happy as can be with them. And building that plant in Delaware for his phase transfer stuff.
Of course, wonderful.
Yeah. So I can do a budget capital estimate with some factors. I get pricing of equipment and so forth. Put a package together, PFDs, equipment list, pricing if they want it, and then send you an estimate. And you'll, like the guys in Australia said, that's a little more than we thought it would be. Sometimes it's going to be, that's a lot more than we thought it was going to be. But then I probably didn't do my job. If it's a little more than they thought, then I know I did my job.
Can you suggest any ways that we could help promote your business?
Actually, I'm not soliciting. dispatch, I don't mind putting this little note at the end. I shut down my website. If anybody has been using my domain email, it doesn't work anymore. I went to this Gmail. I used to be Ken at kenbattleservices.com. My wife would prefer I didn't do anything, but what's funny is people keep calling me on the phone or send me an email and say, hey, do you want to work on this? I got 2 of them like that right now. So that's more than enough. I don't need to solicit any. I have cut down on my fixed costs, you know, some of my office expenses and things of that sort. The big one is shutting down the website. But if somebody has something, you know, you guys run into something, most of you are chemists. If you got some new chemistry, but somebody wants to build a plant, send them my way. I'll give it a try.
Well, that's
Sorry to jump into this again, but
Sure.
I have to laugh. I'm 69, older than dirt.
Okay.
My bride retired this past April, and I had nothing coming into then, and all of a sudden I had 2 new clients. And it is a beautiful thing to help clients that you like.
Yep.
And it's another beautiful thing to be able to say, I'm sorry, I'm too busy. When somebody comes over the transom and you really don't want to, for whatever reason, you just don't want to work with them.
Yeah, the Ascend materials, the nylon 6/6, if any of you have ever worked on nylon, it's some weird stuff. They hired me to consult in one area, and it turned out that I didn't understand the nylon 6/6 very well, and it's gels very easily and things of that sort. And I couldn't really help them with that, but I did get them the thermodynamics of what they needed to do for their job. And I think they're going to go on and build their pilot unit. I don't think they need my help anymore. On the other hand, Roman, the job that Mike Bigwood and I were dealing with, I think we talked to you about it, the cross-linked polystyrene. You remember?
Yeah.
They had some budget issues. They shut it down. They said the project's not dead, but they have a very good chemist there. Mike went down and spent 3 or 4 days with him. He was a very competent guy. They said, well, we're going to work on the chemistry ourselves. Out of the blue last week, that chemist guy, he sent me an email, you know, you're still there? We're ready to build this, actually a commercial plant. And it's a small commercial plant. But anyway, they had, so I think I'm going to get some work out of that in the next couple months. But just falls out of the sky, and somebody that I work with at Floor, he's got an extrusion project that they need help on. So I got a conference call with the guy's boss tomorrow afternoon, and I didn't have to do anything for that. You know, my website was probably not built very well. It looked beautiful. I would get at least 5 emails a day from people that said, I can make your website much better and get you higher ranked and all of this stuff. I said, I don't need it. And I said, the one thing about it is I only considered the website was like a 5-page business card. And it told everybody who I was, what I did, what I can do, how I work, all of that was on there. But I never got a lead from the website. And although there was a time if you did a search, and this would be some years ago, if you did a search for polymer devolatilization consultant, 7 of the first 10 hits on Google were me. And one of them was my website. A couple of them were, well, some of them were CCN. The CCN website had picked up, and then CCN's website as well. That they know how to attract the people there. So I guess that one work, the nylon job, was done through CCN, but not going forward. Okay.
Sorry to interrupt again. I have to
Yeah.
laugh because I never bothered to build a website. I have a CCN page. That's all I ever did. And $35 a month.
A year.
That's
Yeah.
investment. Easy. It works.
And I'll tell you, CCN has given me more leads than anything else. Absolutely.
Very cool.
And I mean, CCN, I got the biggest project with them years back, and with the Chinese. But anyway, Roman, it was Peter Joyce told me, get rid of that AOL address and get a domain name. So that was why it was more to have the email address that said ken@kenbattleservices.com was a good thing. I think that gives you a good bit of, but you don't have to build a website to get that. You just need the domain name.
Well, I think that building a website these days is fairly straightforward. It's you know, it's like 30 years ago or anything like that. And, you know, anybody can, over the weekend can build a website.
Well, you can build a website that looks good, but you're not going to appear in the Google searches.
Well, you will eventually. I mean,
Eventually,
once it goes out. I mean, it takes months before, but it goes out. So yeah. Anyway, I got a quick question on this. You mentioned a couple of times that that you want to run the pilot plant for a long time, and you mentioned a month, or you mentioned 400 hours and so forth. Is that essentially to see that you have it at a steady state, or to make sure that everything is working fine, or is it because you're trying to during that time of running it, you're trying to change various variables to see how much of a change you have in the output or the different parameters?
Right.
What's the point of running it so long?
Well, because the manufacturing plant where it's going to be built said you ain't going to build it here unless you can run it. If you had it, the problem was that the pilot plant was running 2 or 3 days at a time, and this was a pilot plant, a commercial plant that was scoped to run at 90% on stream time. Was the basis of the commercial plant. So you couldn't run 2 days and then repair it for a week and then run 2 more days and so forth, which is what them sitting 1,000 miles away said, hey, that process doesn't work. So it was proving to the manufacturing group that it was a real continuous process.
All right. So what you're saying is you want to run it for a long period of time because you want to make sure that it can run for a long period of time.
It was the operability, right? And
okay.
And did it make the same product on day 1 or maybe day 2 as it did on 15 days later? And I think we had 2 products, and we probably made a couple product change. We might have run 1 week on one product and another week on the other product. And that was basically nobody wanted to touch anything once once that thing got running. Everybody said, just don't do anything. We got to get to 400 hours. And
Okay.
3 engineers working round the clock, and we different shifts and so forth.
The other thing, the other question I have is the pilot plant operators and technicians. You mentioned them a couple of times.
Yep.
About this. Are they special trained or higher trained than the normal the manufacturing operators, or are they pretty much on the same level of technical expertise and education expertise?
Well, the two that I actually operated in, Monsanto in Springfield, Mass, had like a 4-story pilot plant, and they worked on a lot of different processes. And yes, they were plant operators. When they got enough seniority, they said, "Oh, hey, that's a 5-day job, not a or rotating." They had to rotate the shift on the 5 days, but they still it wasn't weekends and so forth. So we had senior people typically.
Right. So I mean, so
young guys like us.
You did not go take somebody who has a master's or an undergraduate degree to do that, to be operators.
And in Uniroyal, I came into the plant cold. I mean, I moved from Belgium to Baton Rouge. Talk about culture shock. But they had my sidekick, and there were a lot of Star Trek jokes about the pilot plant, but I was Dr. Spock and he was Commander, whatever. But he had worked in the plant for years. He kind of handpicked the operators that he knew in the plant. And I had one operator with a master's in mathematics.
Wow.
But he was a plant operator. Because what do you do with a master's in mathematics? Hard to make money. Anyway, plant operator was a better job. I had a guy with a history degree from LSU. I had a former Fighting Tiger band member. And but they had worked as operators in the plant, and they were kind of handpicked. The lucky one I had was that we were dealing with Ziegler-Natta catalysts, so they're pyrophoric materials. And one of my operators had worked 10 years at Dow Chemical and across the river in Plaquemine, and it was an overtime job, and he was one of those guys that sucked up all the overtime. He basically unloaded every rail car of pyrophoric material that Dow Chemical used. And when we were handling it on a much smaller scale, if we were doing something new with those materials, I wanted him there.
Very good.
Trust him. He understood. And he dealt with big scale stuff at Dow, but I could count on him for knowing what was going on with the pyrophoric materials. They were kind of new to me.
Okay. Are there any other questions? Yeah, well, thank you very much. I really appreciate everything, and I learned more over here than I could ever reading about pilot plants. I've learned so much. I really do appreciate it, and thank you very much for volunteering to come and talk to us. It's been a pleasure.
It was good. I know we didn't get a big audience, but I hope you all got something out of it. And just ignore the date on the first page of the slides.
Absolutely.
The one that I sent out. Instead of changing the time, I went a year ahead on it. I changed it on here. I was sitting here ready to do this thing, and before Joanne came on, I said, "Wait a minute, the date's wrong."
You're muted.
Okay, all, thank you.
Hey, thank you. This
Thank
is-
you.
and-
Thank you.
Thank you.
Okay, now see if I